Assalamualaikum and hello everyone. Firstly, let me introduce myself. My name is Puteri and I'm Husna bin Muhammad. Today, I would like to present the final year report titled Volume of Irregular Symmetrical Object Designed by using Lambda Mu B-Spline method. And my supervisor is Wan Nurshahid bin Muhammad Siti. Introduction. In computer graphics, a spline is a curve that connects two or more specific points. In the mathematical subfield of numerical analysis, a B-spline or a passive spline is a spline function that has minimal support with respect to a given degree, smoothness, and domain precision. Any spline function of given degree can be expressed as a linear combination of B-splines of that degree. Besides, B-spline allows the local control over the surface curve. Each vertex affects the shape of a curve only over a range of parameter values. In this analysis, one method of B-spline has been chosen, which is Lambda Mu B-spline method. This method is the extension of interpolating B-spline by the singular bending technique. Lambda Mu B-spline not only have local shape parameter, but also have global parameter. Besides of inheriting the properties of them, Lambda Mu B-spline curves have a good performance on adjusting their local shape by changing multiple shape parameters. Problem statement. In this research, we are focused on drinking bottles. Most of the bottle shapes are closely associated and identified with a specific product followed by their function. I would consider the most suitable shape and design for daily use of consumers. Furthermore, the shape of the bottle produced in the industry has been considered as most consumers prefer bottle with aesthetic design, which at the same time is easy to clean and user-friendly. Besides the smoothness of the curve, which is vital particularly in designing bottles. To design curve, various methods can be implemented. As it is known by many, designing a bottle is not as easy as the requirement of user must be considered as well. To design curve in this research, Lambda Mu B-spline method has been applied and can be implemented. Then the best results such as the curve, the three-dimensional shape, and the value will be shown by comparison using more than one shape parameter. In this research, there are three main objectives to be achieved. Firstly, to design two-dimensional irregular curve by using Lambda Mu B-spline method. Secondly, to design symmetrical irregular three-dimensional objects by using a revolution technique in surface. And thirdly, to find the best shape parameter used in designing three-dimensional symmetrical irregular objects. Of research. Bottle design has been chosen as symmetrical irregular object. The curve of the bottles are to be formed by using Lambda Mu B-spline with degree 4. By applying the technique of the revolution in the split surface method, various designs of three-dimensional bottles can be generated. Moreover, by using different and suitable value of shape parameter in order to obtain the desired design. Then, by analyzing the error, it will help to determine the reliability of all the shape parameters in which the one with the least percentage error is to be considered as the most accurate method. To Abashi Mishra in 2016, Lambda Mu B-spline method is the extension of interpolating B-spline by singular bending technique. Lambda Mu B-spline not only has a local shape parameter but even have global parameter. Besides of inheriting the properties of them, Lambda Mu B-spline curves have a good performance on adjusting their local shape by changing multiple shape parameters. Besides, a bottle shape has been chosen to conduct this analysis. Bottles are available in various designs and surfaces, and there are many alternative methods to generate the aesthetic curve of the bottles. According to Puteri in 2017, as to obtain a three-dimensional bottle, the swept surface method was the purposefully conceived of revolution and translation technique to remodel two-dimensional curve. to the specific three-dimensional object. Revolution is used to generate the symmetric surface. A surface of revolution can simply be formulated as a metric operation where a two-dimensional cross-section curve rotates about an axis in space. According to Rush and Shrivastava in 2017, India River Studies state that the computation of area and volume of irregular structures has become a subject matter of skyrocketing interest since find its application in several areas like agriculture and food processing, healthcare, and lots of more. Throughout the research done by Park and Stefanski in 1998, they enclosed that the relative error is typically a more meaningful measure of performance of a predictor than the absolute error. They discussed that in general, this happens when the range of predicted value is large. Based on their perspective, engineers often think in terms of relative error, proving the very fact that relative error is often more meaningful quantity in engineering applications. In methodology, it will discuss about fundamental concept of B-Spline, fundamental concept of revolution by using sweep surface method, fundamental concept of Lambda B-Spline, fundamental concept of Simpson 3/8, and fundamental concept of error approximation. Result and discussion. In comparing all the curves generated by implementing Lambda B-Spline method, we can show that by applying shape parameter 0, 1, and 2, smooth curves are generated, while for shape parameter -7, negative 2, and 10, the curve form was not smooth. For shape parameter 10, a tangled node form and therefore does not satisfy the shape needed. Each of the shape parameter value of mu that apply in this analysis is 10. As for the distance between the curve and the control polygon, the curve generated by applying shape parameter 1 is the closest compared to the other 5 curves. This is the result of three-dimensional symmetrical irregular object for front view. By implementing shape parameter with value 0, 1, and 2, the object form a smooth, while shape parameter with 7, negative 2, and 10 will result in smooth surface object but with some design. Other than that, the concave shape object formed by applying shape parameter 1 has the narrowest curve on its body compared to 5 object others. Based on this result, it can show that shape parameter lambda equal to 1 and subinterval equal to 18 have closest as approximated volume from actual value. So in error analysis, it can show that shape parameter lambda equal to 1 and subinterval equal to 18 have the least percentage of error. Recommendation. Based on this analysis, we can conclude that the shape parameter that best fit the control polygon is lambda equal to 1. In terms of smoothness, the most suitable shape parameter to be chosen is also lambda equal to 1. From this research, all the objective is satisfied. For recommendation, it is suggested to implement other methods in generating curves, as there are various such as Bezier curve, non-uniform rational B-spline, and so on.